So this is my third session of the week, and I was hoping nobody was going to turn up so I wouldn't have to do it. And then, of course, they go and video me as well. So, yeah, okay. So we're going to go through some features around security, and in particular, stuff that's come in with version 12. So the things we're going to talk about are transfer of ownership, the changes to migration that means you can now do it without install sysadmin authority, the new unload privilege, RACF exit updates, and finally a fair amount on pervasive encryption. So we made a couple of enhancements in Db2 10. We introduced some new database and security administration authorities, as well as the separate security ZPARM. And with that, you can separate Db2 security admin and data access control from system administration. Db2 12 gives you the ability to transfer user-defined objects to another user or role with the new transfer ownership statement. You're no longer required to use the sysadmin or install sysadmin authority to migrate a Db2 system. Instead, you can use install sysopa. And as I've mentioned, we have the new unload privilege in Db2 12 as well. So starting with transfer of ownership. Object ownership carries with it a set of privileges on the object. Because owner privileges are implicit, you cannot revoke them from the current owner. There are a number of ways that you can manage implicit ownership privileges. So you can drop and recreate the object under the new owner, but obviously that has a potentially serious availability problem. You can use the catmaint update utility with the owner option to change the ownership of an existing object from an authorization ID to a role. And to do that, you must also have the install sysadmin authority and define a trusted context with the role as object owner and qualifier clause. But in Db2 12, we have the transfer ownership statement, which allows you to transfer the ownership of an existing object from one user to another. You can issue the transfer ownership statement to transfer the ownership of a database or system object from one user to the other, and that owner can be an authorization ID or a role. The new transfer ownership SQL statement can be embedded in an application program or issued interactively. It applies to the database objects listed here, so database, table space, table view, index and alias, and also to the system object stow group. But you can't run it against any application objects such as packages or plans. A few other points. The transfer ownership statement doesn't change the schema of the transferred object. Transferring the ownership of a database does not transfer the ownership of any other object in the database that was created by the current owner. And the new owner is automatically granted the same privileges that the current owner holds on the object at the time of the object's creation. And Db2 issues a warning when the current owner of an object attempts to transfer the ownership to itself. For the syntax, you can see that we've got revoke privileges on the end of the transfer ownership statement there, and we'll cover that in a couple of slides. So this is an example. So we start with user ADMF002, creating a table SZI10T, and the red bits on the slide highlight that ADMF2 is the owner, the grantor, and the grantee. SecAdam then runs a transfer ownership of table against the one we've just created and transfers the ownership to ADMF003, and as you can see, the fields are updated accordingly. So quite simple. In this example, ADMF002 creates an alias of Peter on the table that we've just created. So again, you can see that ADMF002 is the owner, the grantor, and the grantee. SecAdam then does another transfer of ownership on the table, but specifies alias of in the actual statement. So it's referring to the alias, not to the table. And as you can see, the transfer actually happens on the table, and ADMF2 retains ownership of the alias. So it's just a little bit to be careful of there. Excuse me. In order to successfully run a transfer of ownership, you must have ownership of the object already or SecAdam authority. Install SecAdam or sysadmin authority is not sufficient. And it also doesn't matter what you've got the separate security ZPARM set to, because that doesn't affect SecAdam authority. You can't run transfer ownership against catalog or directory objects. If you do that, you'll get a -618 or a -607. So it'll either tell you that the operation is not allowed on system databases, or that you can't transfer the ownership of anything who's got an owner of sysIBM. When you transfer the ownership of a table, you also transfer the ownership of that table's dependent objects. So that includes any implicitly created table spaces for that base table and any XML objects, and any indexes that have the same owner. Implicitly created lob objects and any explicitly created lob objects with the same owner are also transferred as well. When you transfer the ownership of an object, the new owner must have the same set of privileges on the object as specified in the dependency record of the object. And this is required so that the object can continue to exist. The new owner doesn't need to have any additional privileges for creating the object because it's already created. And this is an example of a couple of failures. So the first one, we've tried to transfer the ownership of an implicitly created object. So you can see there you get the -20355 SQL code, reason code 6. And the second example shows that the new owner needs privileges on dependent objects. So if we create a view and then try to transfer ownership of that view, we get a -20342 because the new owner doesn't have any select privilege on the table. We mentioned the revoke privileges clause. That specifies that the current owner no longer has any implicit privileges on the object after the transfer has been made. So once you transfer ownership away, that's it, it's a done deal. And also the corresponding authorization cache entries for the current owner are cleared as well. So it's all gone, they lose everything completely. If any packages are dependent on an implicit privilege, then the current owner has on the object, transfer ownership with revoked privileges fails, so you just can't do it. For the current owner to maintain access to those dependent packages, authorization must be explicitly granted to the current owner from another source before you do the transfer of ownership. And finally, there are no changes to the grants made by the existing owner, the previous owner. So we have another example. So again, we start by creating the table under AMF002, and then we've still got the same red columns at the top. ADMF002 then runs a bind package which has a reference to the table that we just created, which is fine. But then secadm tries to run a transfer ownership on the table, but it fails because ADMF3, which is transferring the ownership to, doesn't have any select privilege on the table. So you can't do that either. And that is it on transfer of ownership. It's a bit of a dry topic, but it's all new in version 12. So the next thing is the changes to the install and migration process so that you don't need install sysadm anymore. So before Db2 12, you had to have sysadm authority to perform Db2 installation or migration tasks. You also had to have install sysadm to run the DSN TIJTC job and the catmate utility. But these authorities provide unrestricted access to all user objects in the subsystem, which in some cases is unintended, unnecessary, and can possibly pose a security risk. So using the install sysopper authority helps reduce those risks. So in Db2 12, the install sysopper authority provides all the privileges that are required for installing and migrating Db2. The overall process of the migration hasn't changed. Everything is still the same under install sysopper as it would have been with sysadm authority. And you can use install sysopper as long as the primary or secondary authorization ID that performs the installation or migration tasks has the install sysopper authority. The current SQL ID that processes data definition statements must be set to sysinstall, which owns all of the system objects created by installation sysopper authority. And the owner option for the bind and rebind commands must be set to an ID that's authorized to bind and execute SQL statements in a package. So in order for install sysadm to do that, it's had to be enhanced with the things on the slide here. So it can now execute the catmate utility to install or migrate to a new release. It is able to issue the new in Db2 12 activate new function command, which is required to go to and from different function levels. It's able to set the SQL ID to sysinstall regardless of the separate security system setting. It must have access to all the catalogs and tables in the system, and it has the bind agent privilege so that another owner can be specified when you do those binds. So all those things have been changed. And it also has the ability to create the system-defined routines. Again, you have to remember to set your SQL ID to sysinstall. Excuse me. And when that SQL ID has been set to sysinstall, syshopper gets the ability to issue that create, alter, and drop statements that manage most of the objects in the Db2 system, with the exception of security objects. It can't do anything against those. The extra privileges are needed to create objects, so views, functions, and triggers, and these procedures and functions can be created in the systools and sysfun schemas. Install syshopper can also issue grants on system objects, as we've got here, so as you'd expect, tables, database, table space, buffer pools and stow groups, and all the other bits and pieces that you would expect it to need. And then we have the new unload privilege. So I think we mentioned this in one of the sessions today already, but in Db2 12 we have this new unload privilege to control the execution of unload utilities. So in Db2 11 you just need the select privilege to be able to unload data from a table. And in Db2 12 this new feature is delivered switched on. So if you do nothing as part of a migration and you have unloads that are running with select authority, those jobs will fail. Those unload utility jobs will fail. So you have two options. You can use the new ZPalm auth compatibility, and you can set it to select for unload, and that will revert to the Db2 11 behaviour, so it will still check for the select authority to see if the unload can happen. Before you get to the activation of function level 500 or higher, there is a new IFC ID trace 404 that can be used to identify the usage of select privilege for unload utility access. So even back in Db2 11, you can monitor for that IFC ID, and excuse me, and if you have unloads that are running with that authority, you can find out where they are. And you then have the option to either grant the new unload authority or set the ZPalm, whichever way you want to handle it. You can actually do those grants in Db2 12 M100, but they doesn't actually take effect until M500. And then obviously we've got the associated grants and revokes of the unload authority, as you would expect. Excuse me. I've just got one page on RACF exit updates, and it links into the previous topic because it's just an enhancement to support the new unload privilege. So we've got the new resource in RACF for that. And for update and reference operations on tables, table qualifiers and table names are each truncated at 100 characters. So the column name is truncated at 30 characters. So it's just need to be careful if you've got some extra long object names there. And then moving on to the bigger topic of Db2 support for dataset encryption. So Db2 can now transparently encrypt data at rest without database downtime or needing the administrator to redefine objects, which could obviously be disruptive, and no application changes are required. You can encrypt the active and archive logs, the catalogue, the directory table spaces, and any user table spaces that you want to. And in order to do this, we exploit some new ZOS DFSMS dataset encryption function that's been delivered in ZOS 2.3 and 2.2. And additionally, Db2 12 has some extra controls that help you set up the encryption policies using Db2 interfaces rather than having to go through the others. So DFSMS encrypts and decrypts records when they are written to or read from disk. And we can do this for sequential and VSAM datasets as long as they're in extended format. The encryption used is AES 256-bit key. We use a 64-byte key label. And I always have to remind myself what all the acronyms stand for. So ICSF is the Integrated Cryptographic Services Facility, and CKDS is the Cryptographic Key Dataset. And I don't like saying those because they're a bit of a mouthful. So understanding policy-based dataset encryption. So in order to define a dataset as encrypted, you specify a key label during the creation of a new dataset. You can do that via a SAF dataset profile, via an allocation in JCL TSO, or via an SMS data class. During the dataset open, DFSMS checks that the user has access to the key label and then specifies the key label to ICSF to retrieve the secure protected key from the CKDS, from the cryptographic key dataset. ICSF locates the secure key in the CKDS using the key label specified by DFSMS, and then it calls the adapter to unwrap the key value from the master key. It then rewraps the key value under a CPACF wrapping key to make it a protected key, and that protected key is then stored in the ICSF cache. So it's all rather complicated, but happens quite simply. Now, the important thing for us really is that this is all completely transparent to applications. Data remains encrypted during backup and recovery or migration and recall. In-memory system or application buffers remain in the clear, so that's not encrypted. And access to the key label is controlled through SAFA permissions in addition to traditional dataset permissions. And segregation of duties is maintained. Storage administrators who need access to the dataset but don't need access to the key label. So we have a number of steps to enable encryption. So the first thing is the ICSF admin generates an encryption key and key label, and they're stored in the ICSF CKDS. Far too many letters. Step 2, the security admin sets up RACF for the use of the key label. So this allows the secure key to be used as a protected key via ICSF segment in the SIM CPACF wrap and SIM CPAC threat. And it also permits Db2 the use of the key label. So in RACF, they allocate the new resource in the facility class. So that's the security side of it done. Now, step 3 is where you start having some choice in the matter. So you can do step 3 either via security, via the database, or via the storage admin. The key label has to be associated with the desired dataset, and in RACF, so if you are going to do it in RACF, you would alter the DFP segment in the dataset profile, or if you're going to do it in Db2, the key label is set up for the system and user objects, or you can assign the key label to the data class in DFSMS. So you have different options as to what you can do there. Once you've done that, the database administrator can now migrate the encrypted data via a non-disruptive online reorg. So you have to do the first bits in order to be able to just apply the key labels on the database side of it. So in a little more detail around step 1. So the ICSF admin generates the encryption key and key label, which are stored in the CKDS. Once they're there, they are associated with secure AES 256 keys. And fairly obviously, the CKDS must be accessible across systems in a sysplex and replicated to sites that will need access to that encrypted dataset. In order to create the key labels and data keys, there's an ICSF service, CSN BKGN, that you use to generate the 256-bit data key, and then there's the CSN BKRC2 to create the key label in the CKDS with the associated key. And the link at the bottom is to a Rex that goes through an entire worked example of how to create the keys. It's nothing to do with me. I nicked it from one of the security ladies in SVL, but it's really good. It actually just goes all the way through. So once you've got all your keys defined, then you need to do some RACF setup. So the security admin enables the system to create the encrypted datasets when specifying key labels outside of the RACF dataset profile. The general resource class CSF keys is set up to enable the use of ICSF keys, and we've got an example of the sort of code or what that looks like. So in this case, our Db2 address space ID is the sys DSP in here. And the CSF serve class that ICSF uses to control access to the cryptographic services is protected. So then, once you get to step 3, you said you've got the 3 different options. You can do it in RACF, in Db2, or in DFSMS. If you want to set a key label in the DFP segment of RACF, then you just use the data key keyword. If you want to do it through Db2 admin, then you can set a new key label using the encryption key label ZPalm. that's only available once you get to V12R1 M502. So this is the second of the continuous delivery function levels that we delivered back in the summer, I think it was, for this one. And other things that came with, we get onto later. So once you've got your encryption key label in the system parameter, you do a set sysparm command for the zparm to take effect. It has a group-wide scope, so it affects all members of a data sharing group immediately. And because it's a security-related parameter, you need install sysadm or the secadm authority to set it. And you must remember that you need the DBM1 and master address space IDs must have access to that key label as well, otherwise you're going to be in all sorts of mess. And then finally, your other option is that you could get your storage admin to set a key label using IDCAMs defined for active logs or the DFSMS data class. So that's where you have your options. There are all sorts of different objects that you can encrypt once you've got all your keys defined. So starting with the active logs, if you want to encrypt new logs, you define the active log dataset as encrypted and just issue the set log command new log option, and that will add the newly defined active log dataset to the active log inventory without stopping Db2. If you want to encrypt all active logs, you do have to stop Db2, copy the contents of the active log dataset to an encrypted dataset and then restart Db2. And from there on in, new archive logs are automatically encrypted based on the key label setting. And in order to encrypt the catalogue and directory table spaces, you just do a reorg table space. You just do a reorg table space on those, with the exception of sysutilx, which for some reason you need to do a reorg followed by a rebuild index all if you want to encrypt that as well. Once you have encrypted things, you can see the details about the encryption key using the DFSMS interfaces or in the SMF records. Once you get to version 12.502, you get a new run report table space set utility to display the key label associated for each catalogue and directory table space with a new show key label option. You can do a display log to obtain current key label information for the current active log datasets, and you can do a display archive to show you the key label information for archive log datasets. So once it's all encrypted, you can see what key labels are being used. So when it comes to encrypting user objects, it's fairly similar. You still have the same three options. It's where we get a little bit repetitive. So again, RACF in Db2 or storage admin. And again, once you are at M502, then there is a key label option that you can just put on the create alter table or slow group commands. And that is what it looks like. So we can just have a new key label option, and literally it's key label, and then you specify the key label, the actual key label itself. There's nothing much there, I don't think, else. Yes, universal table space or classic partitioned. So as always, it's a restriction to the universal table space types. And to encrypt your user objects, again, you use a reorg just to encrypt existing table spaces. Any new table spaces or partitions that you define are encrypted using the key label based on the hierarchy. So once you're at V12R1 M502, the show key label option of report table space set becomes available. So you can see what you're doing there. And a thought on compression. Db2 compression works seamlessly with dataset encryption, with the compression being performed first. The performance in our own internal testing, we've seen there is a little bit of a throughput loss with encryption. You can see the difference there, so 2.3% loss on a Z13 and 0.4% on a Z14. So obviously with the Z14 you have the Crypto Express is built into the chips, so that's why it's a newer version, and it's actually built in, so we don't have to go off the chip to do it. And again, there is a little bit of elapsed time increase, but it's not really noticeable. We've not had many problems with it so far. And unfortunately, I've really rattled through that, and that was all I had. So, any questions?
So the difficult bit managing keys.
Yes.
When keys change, you've got to re-encrypt.
Yes. Oh, sorry. Yeah, I have to repeat the question. So the question was around, is the difficult bit is encrypting is managing the keys, and yes, it is. So when things change, you do need to make sure you update everything all the way through. Yeah.
So when if you cut over to using that with your Db2 and Z-part, then you would have some tables that weren't encrypted until you reorg them, and some that were because you'd reorged. Suppose it would just like reorg both of them before.
Yeah, just ripple through.
But I guess you'd feel a bit uncomfortable if you really wanted to secure the data, and some things were still not encrypted.
Yeah. So it was more of a comment than a question, really. But the fact is that if you set the ZPARM, then you would find that objects would only become encrypted as they go through a natural process and end up getting reorged. So you would end up with a mixture of encrypted and unencrypted through your system. So I guess, yeah, if you wanted to protect everything, it would be a huge effort to go through and reorg everything. I don't have many customers actually doing this at the moment.
So how have you, was there a command to tell when it's been encrypted, physically encrypted?
The question was, is there a command to show if something's physically been encrypted or just pending encryption?
I mean, obviously you check the reorg.
Yeah,
I think you can just cache the data set, so you see the key label,
yeah.
security label,
Yes,
so
yeah, key label.
that means it's an encrypted data set.
Okay. Anything else? No? Thank you very much. I apologise that was so quick. I thought I had some more stuff in here, but that must have been a different presentation. Thank you very much.